Welcome to This Explainer. When most of us think about the end of the universe, we probably just picture a light slowly going out, just this incredibly slow dimming over trillions and trillions of years. But when you really dive into the science, it turns out it's not quite that simple. Today, we're going to look at the actual data and the mathematical models that project exactly how everything we know might come to a final close. Okay, so let's just jump right in and address a truly unsettling thought. Instead of a slow, predictable fade to black, could it all just end right now? Like right this very second? Well, theoretically, yes. It absolutely could. Now, while it is extremely unlikely to happen anytime soon, the mere fact that our mathematical models allow for the universe to suddenly cease to exist in our lifetimes is, quite frankly, fascinating and genuinely terrifying. But to figure out which of these theorized endings will actually happen, we have to understand the forces driving our universe right now. Which brings us to our first potential fate: torn apart or crushed. To understand these more dramatic cosmic conclusions, we really have to look at dark energy. So, dark energy makes up roughly 68% of our universe, and it's the engine driving cosmic expansion. But what if it actually grows stronger over time? Cosmologists call this phantom energy. Think of it like a really bizarre rubber band that, instead of relaxing as you stretch it, actually pulls harder the further you pull it apart. If this happens, the expansion accelerates so wildly that it overwhelms literally every bound structure in existence. This leads us to a scenario physicists call the Big Rip. Just imagine this sequence unfolding. First, the largest, most loosely bound structures go. Entire galaxy clusters disintegrate as gravity just utterly fails. Then our very own Milky Way is stripped apart, star by star. Eventually, solar systems fail entirely. Earth would literally break free from the sun long before the sun itself even dies, which, hey, I guess saves us from a solar flare, but would absolutely ruin your weekend. Ultimately, the expansion becomes so violently powerful, it tears apart atomic nuclei. If current dark energy values shift in this direction, it could end everything in about 22 billion years. But what if gravity ultimately gains the upper hand? Just picture the exact opposite of what we just talked about. Instead of the universe being violently torn apart, imagine it being violently crushed back together into a single point. Back in the 1960s and 70s, this was practically the standard model. It's known as the Big Crunch. Basically, if the universe's average density ends up exceeding a critical value, gravity will halt the expansion and slam it right into reverse. Suddenly, galaxies rush back together. In the final minutes, the sky's background radiation shifts from invisible to visible to this absolutely blinding glare, vaporizing stars before they're even crushed. Everything gets squeezed down into a single, infinitely dense point, which, you might notice, is so incredibly similar to the Big Bang that it actually leads to theories of a big bounce, meaning a cyclical universe that just constantly restarts itself. But let's move on to our next section: spontaneous erasure. We've talked about being crushed, we've talked about being torn apart, but this builds into an even stranger possibility. Have you ever heard of vacuum decay? It's a wild concept. Think of a ball resting at the very bottom of the deepest possible valley. That represents true, perfect stability. But physicists who measure our universe suggest we might actually be more like a ball resting on a tiny little rise on the side of a mountain. Sure, it looks stable right now, and it could probably stay there for eons, but theoretically, there is a lower, much more stable state out there somewhere, and eventually, that ball could roll down. If that happens, a tiny bubble of this new, more stable reality could just spontaneously form. No warning, no trigger whatsoever, and this bubble would expand outward at the speed of light. If it formed tonight, somewhere across the galaxy, no warning signal could ever reach us faster than the bubble itself. It would just wash right over us, instantly rewriting the fundamental laws of nature. It's essentially the ultimate cosmic delete button. Atoms and stars simply could no longer exist in this new reality. Now, if instantly changing the laws of nature sounds extreme, wait until we hit our third scenario: the quantum breakup. This is where space and time just straight up fail, deep in the unimaginable extremes where general relativity and quantum mechanics collide. We are talking about the very foundation of reality itself here. Down at extremely microscopic scales, our familiar laws of physics simply stop functioning. Space and time no longer act as a smooth, predictable stage for things to happen on. Instead, the math describes this seething quantum foam. Tiny, chaotic fluctuations where space-time itself constantly bubbles in and out of existence. Just to give you a sense of the scale we're talking about, this chaos happens at the Planck length. That is just over 10 to the power of minus 35 meters. To put that completely mind-boggling number into perspective, a single proton is roughly 20 orders of magnitude larger than this. We are zooming in so deeply that the very fabric of existence starts to fray. And that leads to a full-blown space-time breakup. In this scenario, it's not matter that disintegrates, it is space-time itself. Think about that for a second. Without space, there are literally no physical positions. Without time, there is no sequence of events. The whole question of what happens next effectively loses all meaning because there is no longer a later for anything to happen in. It's a true mathematical end to reality as we understand it. So, with all these deeply terrifying options on the table, tearing apart, crushing together, instant erasure, or the literal breakdown of time, what does the science actually say? That brings us to our final section, the most likely end. When you get down to it, it all hinges on a fairly straightforward matrix. Our fate is entirely dictated by how dark energy behaves over time. If it strengthens, boom, we get the big rip. If it weakens, the big crunch. But here's the thing. Current measurements heavily suggest that dark energy remains fairly constant. And because of that, a scenario known as heat death is considered our most statistically likely fate. The easiest way to understand heat death is to think about a hot cup of coffee sitting in a cold room. That temperature difference causes heat to flow, right? And that flow means things are happening, energy is being exchanged. But eventually, the coffee and the room are going to reach the exact same temperature. There's no more gradient. Without a temperature difference, there's no usable energy, no chemical reactions, and no new structures form it. And that is exactly what the slow, agonizing reality of a heat death looks like for the cosmos. Stars burn through all their hydrogen and simply run out of fuel. Gas clouds thin out, leaving less and less raw material for new stars to form. Galaxies that are blindingly bright today will, in the distant future, consist only of dead or dying stars. The universe just gets emptier, darker, and so quiet. Everything technically continues to exist, but nothing actually happens anymore. Trillions of years from now, the cosmos just runs out of power, completely rendering itself obsolete. It's a very somber, almost poetic realization, isn't it? Our chaotic, vibrant, wildly explosive cosmos will most likely end in an absolute, motionless quiet. No massive explosions, no dramatic tearing of the fabric of space, just an eternal, heavy silence. Which leaves us with this final, haunting question to ponder the next time you're outside looking up at the night sky. When the stars finally do burn out, when all the heat dissipates, and the grand clockwork of the cosmos ticks its absolute last second, what comes after absolute nothingness? Thank you so much for exploring the end of everything with us in this explainer. Keep questioning and keep looking up.